just run down the escalator. I think that's a proper emergency exit path. Then I think we have some Q&As here. Where was this the first one? Which one was the first one? Actually, maybe we can just do the Q&A as a show of hands. But you can also use your phone. You know, people tend to like QR codes if you can scan that. But maybe yes. Have you ever been involved in open source? And I guess involved means, you know, in some way provided support or maybe contributed to open source. No? Yes? I see some hands. Some have their phones up. You can also, vote on the phone. We're very happy here to welcome AFFiNE to Singapore. It's really great to have the team on the ground. They are contributing, working on some very exciting open source projects, a multitude of them actually, and excited to have them here and give you an introduction to what they are working on, and then also dig a little bit deeper into the technology that's in use. I'm very excited for the last talk, so definitely make sure you stick around for that. I think there was another one. Yeah. Which company do you know? Who here has heard of AFFiNE before? And I guess that's a bit skewed because there's a couple of folks that work at AFFiNE, so you probably have heard of AFFiNE before. If not, you're in the right place. You're going to hear a lot more about it. Maybe a quick show of hands, who has heard of Supabase before? Okay, that's a good amount. That's good. Still some folks who haven't heard, so that's great. You're also in the right place. We'll talk about Supabase as well. And yeah, I think with that we can actually kick off the first talk. We have Ivan from AFFiNE here, actually giving us an insight into what AFFiNE is and you know, all the exciting projects they are working on. Thanks so much.
Makes me nervous. Never mind. Oh, so. It's not. Oh, hosting services. Something wrong with this. Okay, it's as the signal. The signal there.
Sorry, I have let's just try this. So the laptop is recognized.
I have tried it. It's happening and actually fine.
While we're figuring this out, there is a bunch of McDonald's around. Do help yourselves. Yeah, there we go. Just gonna.
I hope it could take a bit longer for everyone to get. Well, anyway, sorry for the technical difficulties, but things are fine just now.
That's fine.
So perhaps. So it's really my honor to be here, and my name is Ivan, and you can see my GitHub ID doodle wings. and I'm the co-founder of AFFiNE. I created this editor, and I'm currently leading the team building this web front end. So, and before joining AFFiNE, I have spent years working on things like response editing, graphics editing, real-time collaboration, things like that. And today's also my first time working. So joining AFFiNE is my the first time working fully open source, but things just kind of fine for me. Things before this, I also have some experience embracing the open source communities. And well, today is also my first time in having an English talk offline, but I think things should be fine since our product is fine. The offline talk here should be fine because our product is an offline first product. So, and first, before we get started, we can have a very quick look of what we are building, which means what AFFiNE is. You can see this is our client. You can see we have different versions, but AFFiNE is basically a knowledge base, and you can check out AFFiNE.pro as our landing page. And basically, it could provide an editing, all-in-one editing experience. Things like it just looks like you are doing some basic markdown editing stuff. But when you click on the whiteboard mode, the content are automatically shifted into the whiteboard. And you can think about we are kind of an open source alternative to big products like Notion or the Miro whiteboard or the Monday for task management. We build some things into it. And the cool stuff of our technology is that all the content models you are seeing here is collaborated by default, but you also own the data, which means that the network for us is optional. And which is not a very easy goal because when you are using a web app, the data is on the server side. Well, that's really another big topic, and we won't dive into too much technical details today. So it really feels good to have using our own products to show this presentation. And so today perhaps it's more about some basic stories of what brings us here. And perhaps this is the page about how we have the cold start. And if something to be highlighted, I want to quote that you just don't need to wait for everything to be ready. Because the first prototype of AFFiNE was very different from what you can see now. You can see this live demo, and it was a web page, and you can also switch between different modes, the paper mode, the address mode, and there has some features that are never being done perhaps a year ago. And it took about more than 4 months of development and to build that prototype. But it has pretty much stability issues, and so basically, but it simply could work and can serve as an interactive prototype, but just with that degree of completeness. It has gained 10K stars within 40 days on GitHub, and it was also the #1 in GitHub trending that month, and with 0 paid promotion. So that's something that the team is very proud of. So when we look back from the starting of the AFFiNE project, first I can see that people are really buying some points. Because, for example, the most sensible features at that moment is that we unify the documents and the whiteboard, and you can see from that prototype to the current version that this is kept, and these are pretty much the novelty, and that really matters. And another point is that the community is really have a very high tolerance to open source products, and although you maybe have a very some architectural issues or things like that, but they are really permissive, And where there are some people that just keep on trying new things, they will give you very positive feedbacks, and that is very that means a lot to the team at that moment. But we want just doing something that is not going to be production ready. So we are not just willing to ship a toy. So the next part of our story is about to build a production ready product. So the point at the moment is that you need to be more user-centric rather than so-called investor-centric. But having that demo is already good for having complete a new round. And anyway, the point is that at that moment, the previous demo, you will see that for the official team at the moment, the bugs are not converging, which means that once you fix one bug, it may bring 2 new bugs, and that makes it that forever could not be reached a stable state. So if you find that the project has these tendencies, a tiny rewrite is necessary, and that was the time I joined the team and started to building a project that is what you can see today. So that story has the strategy that we doing things by step. That for every step we ship a usable subset at every major release. The first stage of the refactoring only produces a pure markdown editor, no extra UI widgets or things like that, just markdown editing, but things could work. And that is the moment that we enforce our team into dogfooding, and we were really using it, and this brings us to the positive feedback loop. And so for the second stage, we built the UIs for things like this. You can see this is called the stash menu, and you can all these kind of the widgets. You can drag things into and to insert them, and these UIs are for the second stage. And for the final stage, not the final, but the next stage, we added the previously complex content. For example, you can have the table view and have it can be used as a multi-dimensional table that could serve as a spreadsheet, and the whiteboard is also polished. And so when we move back, you can see that is how we break things into some reach progressive goals, and using the dogfooding to help building the quality better. So at this moment, the team's responsibility is not only about to deliver new features, but every member has some core subsystem or modules to be responsible, and he will try to check the issues that makes the quality better. So the next part of the in our story is that on the journey to we build AFFiNE, we want to make our work scale, and it means that we need to hire the better people that could tackle the more complex system design in the editors. And that is the point that we found that open source really shines things. And you can see that there are some community people, they are just interested in the idea you propose, and they volunteer in contributing into our products. And that was the way we built the sponsor relationship to some of our core community contributors. And also in another way, having a product with good traction and momentum is also persuasive when you are trying to reach out some brilliant community people. And this also brings a positive feedback loop for our story. And another part of how we run our projects is that we, after some different choices, we finally still choose this using the GitHub as the single source of truth for processing all the development engineering affairs. So the good news is that you can have a more truly building public style that can let outsiders engage. You can, for example, if you can check out our GitHub project, and the first view will be the help wanted, and we will tag some perhaps some good for beginners issues, and some of the open modules for you to for anyone who is interested to build a design. And each of our members are responsible for some of our core modules, and this just works. And it also brings comparable matrices, and which I could simply share here as the ratio between the issues you open and close. The more issues there are on the backlog, perhaps that means that there are more issues that are not got properly maintained or things like that. So we are trying our best to lower the ratios and just to lower the entropy, I think. So, a very brief introduction of the commercialization with the open source is that we are actually using the so-called open core model, and which could be mutually beneficial for community and commercialization, since the open source approach really offers the initial exposure, since the GitHub has great traffic for very interested developers. It serves kind of like Treasure Hunt for many developers. And in our case, it also offers much lower the trial barriers. For example, you can easily try out our web version. If you are interested in our product, you can click the try demo online. And if you visited our repository, you can easily find out a Docker image to build it into to integrate into your environment. And so this makes these things a lot easier, and we can also build a much more open ecosystem. For example, you can see that some of our competitors kind of notion they are using a closed ecosystem, can have plugins or things like that. And that is in our plan to help with that. And on the other hand, you can see the SaaS version is, well, coming soon. and in our goal, in our plan, it could help us to bring the sustainable income and things we are having, doing actually the SaaS business at the moment. And so, but I think there could be another further step that in our plan, which is that for the year of developments, we have tackled tons of problems in things like text-to-text editing and real-time collaboration and things like that. Some very complicated technical challenges, and pretty much of them are pretty general purpose. So in our mindset, we believe that building collaborative applications shouldn't require this much effort to reinventing the wheels. So that's why we also open source the infrastructure, the general purpose infrastructure that we built behind AFFiNE. The one is that I'm in charge of is the block suite, and it's both the editor in AFFiNE and our front-end collaboration framework. And the other project is Octobase, which is in charge of Brooklyn, and he will speak briefly later, and it's our backend infrastructure. Well, they are not pretty much ready to open for the very public reusing, because we are currently prioritized supporting AFFiNE, but we are very willing to offer developer a much better experience into building the collaboration applications for next generation. So that's pretty much for my talk, and thanks for listening.
And did you have the QR code for the Q&A?
Sure.
We forgot to show it. I think I also have it on the...
There are some questions.
But otherwise, if anyone has a question in person, feel free to ask it now while we switch over. Okay, so yeah, if you have any questions for AFFiNE, you can put them in there. Or, you can raise your hand now while you're here.
Question about AFFiNE or and
Yes.
last row.
Otherwise, I can ask a question.
Yeah, sure.
How do you think about data representation if it's open source? Do you also have like an open format and how you store it? I'm thinking of, especially if you have the different forms, do you choose like a JSON format?
That's a very interesting question, and since because in general, in traditional knowledge base, perhaps the representation of, or you can say the single source of truth of a document could be a plain text file, for example, the Markdown or DOCX or things like that. But in our design, we chose a data structure called CRDT as the single source of truth, which means that the document which we modeled it firstly as a block tree, it will be encoded into kind of a binary format. But the metric is that any incremental update to this binary data structure could be incrementally broadcast all over the network, and no matter what the sequence you merge these updates, you can get the eventual consistent format content, and that makes a lot of sense when you want to collaborate in a decentralized way, and that is how AFFiNE is built on top of, and that is also why any application built with our editor block suite can be collaborative from day one. And we have also built a documentation website. You can check out the blocksuite.affine.pro and to see some of our basic system engineering documents in this area. So I think that could make some sense to you. And I'm not sure if that's answered your question. Yeah. Okay. And any more questions? Yeah.
In your previous slide, you said you also open sourced the backend. How did you make that decision? What are the benefits?
Well, the application type that we are building is actually called the so-called local first application. It means that in this type of apps, every client hosts a full duplicate of the data. That since here is Singapore, I think pretty much people knows about blockchain. It's a bit kind of like that. You just or in another mental model, kind of like Git, and Git duplicates the whole repository into every peers locally, and that is very similar to our model. The only difference is that we don't conflict. So to synchronize the content in this kind of application, a dedicated server is not the main effort to build. So we just choose to open source it, and we hope this kind of things could help when building this kind of infrastructure. And I think Brooklyn could offer more detailed explanation for its talk. Okay.
Thanks.
And any other? Yeah, please.
How do you guys think about what to build, because you guys are open source and also funded?
Yeah, what's the target? I'm not sure.
Because you're funded and you're also open source, how do you guys decide what to build? For the community or to make profit? Like, how do you guys
That is a very interesting question. And basically, if you take a look at GitLab, not GitHub, and you can see that all of its source code is open source. But if you want to use some advanced enterprise features, you need a license, and if you want to self-host, you also need to have the license. But the code base is still open source. It has no conflict, and you can use the license to handle this kind of problems. And having the open core means to that for our side, we will keep building the infrastructure no matter the web parts or the backend parts open source. But you can choose what kind of degree you are using, and using our SaaS service or use a self-host service, but that also have the license to be commercialized. That won't be conflict. Point.
Basically, you built for the community until the investors start chasing you down. Then you're gonna come up with some ideas.
Say Supabase.
No. This is a personal joke, not affiliated. Read the disclaimer on my Twitter. No.
So, any other questions?
Yeah. Otherwise, yeah.
Was that Electron? Was the app? Is the web?
Oh, the desktop app.
Yeah.
Yeah, Electron?
Electron?
Yeah, you get a point.
Is it like, do you have any issues with it? Because people say that it's slower. Or like,
Yeah, we switched from Tori.
Oh, from
Yeah, from Tori to Electron because Tori brings up many difficulties in Windows.
But Rust.
Well, Rust. Well, Rust, that's a good question. And Brooklyn is the proficient in Rust, and I think he will share more thoughts on that. Sure. So perhaps that's all for my part.
Awesome.
Thank
Yes.
you guys again.
Thanks so much. 大家好，我是雷声。This is going to be my first talk in Chinese. No, unfortunately, definitely not there. But yeah, that's pretty much where my Chinese ends. I can order my bubble tea, but so I'll survive. Let's put it like that. Yes, thanks so much for joining. I'm Thor. I help developers build. So I work for a little company called Supabase. I know some folks already said they've heard of it. That's great. I have, so the QR code on the left is just the link to that page where I just have the resources basically I'm using for this talk. And then on the right you can ask questions kind of throughout the talk, you know, as you kind of think of them, you can put them in Slido. Yes, this is going to be interesting because I don't have a microphone stand, and I'm gonna. Should I sit down? Should I stand? Not entirely sure. We'll figure it out as we go along. Now, Supabase, yes, open source. That's kind of the theme of the night, so we called it an open source meetup. We're the open source Firebase alternative, if you want to put it like that. It helps with the SEO. You know, a lot of people search for Firebase, so I think that's sort of the main thing there. Probably the same with Notion. Helps with SEO as well. But yes, so basically, you know, it comes from, we love the developer experience of Firebase, right? If you've worked with Firebase, getting started is super easy. Eventually, it might get a bit hairy, but you know, it's kind of the idea of taking the developer experience from Firebase and applying it to a relational database. And Postgres, open source relational database, been around for I think over 30 years. I post about sort of how you know, proposals get merged into Postgres. It's quite interesting because it's not on GitHub. But yes, so basically the database is the foundation of everything. So that's Postgres, and we're pretty much all in on Postgres because Postgres is so powerful. It basically is like using a cheat code. So we're using things like authentication. So that's also we're using a server, an open source service called GoTrue. Was originally built by Netlify back in the day for Jamstack sites. We've kind of forked off of that. And the authentication actually sits on top of the database, so all the user data lives directly within an auth schema within your database. And then we're using the JWT with the role-level security policies, which is a native concept within Postgres, to actually restrict access to data which means that we can put kind of this auto-generated API layer on top using an open source project called Postgres. Yeah, it's confusing with the names, but REST, get the idea, Postgres. And that actually allows us to automatically generate REST APIs. We also have GraphQL APIs built in into Postgres with a Postgres extension, and so that's the other exciting part of kind of the Postgres ecosystem there. All right, I probably need to be faster. Okay, let me see if I sit down and kind of move the thing every once in a while. Let's see. Did that work?
Oops, coming. Yep.
Okay, sweet. Yes, Twitter, if you're not following us, feel free to do that. But actually, while we're here, so we just launched Supabase Vector on Product Hunt. So let everyone go to Product Hunt and maybe upvote. Let's go while we're here. Maybe we can. Does that work?
Upload it.
Yes. So if you go there and you do that while I tell you about Postgres Vector. So who's familiar with kind of building AI applications, embeddings, vectors, kind of all that fun stuff? Anyone? No one? Ah, yes, back there, lovely. So basically, you know, the idea is that you take kind of something like human language or vision and turn that context into a vector. Did everyone manage to scan the QR code? Then I can go and show you some visuals that help with the explanation. Okay, very good. So if we go here, yeah, let's maybe look at this. So there's a blog post that explains kind of, you know, working with embeddings and vectors in Postgres. And so basically it's kind of this idea here where you're kind of translating, you know, something like human language and the context of human language into basically just numbers, kind of a vector. And if you look at this here, so we have kind of, this is just two-dimensional, right? And say we have something like the cat chases the mouse and the kitten hunts, what is this saying, rabbits? Rodents? Ah, there we are. Contextually, that is fairly close to each other, right? You have a cat, a kitten, a mouse, a rodent. And so if you translate this into kind of the vector space, this context will be fairly close to each other, right? Now, if you have something like I like ham sandwiches, that is fairly far away from kind of the previous two statements. And so if you put this into this vector space, what you can then do is you can perform vector similarity search or kind of proximity search, where you're basically looking, okay, for two vectors to be close to each other, then there is some contextual relationship. And so basically now if you're putting, you know, language or images, if you can translate that into kind of this vector space, and you can store these vectors and then perform, you know, kind of the search on it, then you can build fairly powerful applications. And so pgvector is a Postgres extension that allows you to store vectors of different dimensions right within Postgres and actually create indexes on top of that data, on top of those vectors, and then perform kind of these search operations within Postgres. And so if you're working with something like OpenAI, where you can turn kind of that context like human language or images into vectors, you can then store that into the database using Postgres or, you know, Supabase Vector, which is basically a managed pgvector Postgres kind of bundle. Now, obviously, to kind of represent something like visual context or human language, you need a lot more dimensions than just these two, and so you actually have like vectors with, depending on the model, more than 500 dimensions, and obviously that's kind of very big numbers. But we'll just use this for kind of visualizing this. If you look at kind of the docs, so we have some documentation. Supabase Vector is sort of the soft launch that we've done now. We have the vector store that kind of allows us to store these embeddings using Postgres and PG Vector. There's a Python client library called Vex that kind of takes care of the indexing, creating of the collections, performing queries. So if you've worked with something like Pinecone, which is kind of a dedicated vector database, sort of specialized on vector data, it is kind of fairly similar to that experience where you're creating collections and you're querying those. You're kind of upserting things into your collections. We'll look at an example in a bit. But kind of the exciting part with PG Vector is that you can actually, because your data is sort of within, where is it? Is it this? No, that's not. Anyway, you can go through the docs yourself. But the idea is that you have both your vector data as well as your normal relational data or your files. So we also have unstructured data like file storage kind of as part of the Supabase stack. So everything sort of is coexisting within the same database, the same ecosystem, and all the parts are open source. You can use them separately, or you can kind of bring all the different bits and pieces together, and sort of that's kind of the philosophy within Supabase. Open source, modular, so like each piece you can take on its own, self-host, or obviously then our business model is we host it for you and we manage kind of the hosted database service for you, and that's kind of where we make the money. Okay, great. So let's actually dive into some examples. And I personally, I'm a JavaScript fan, but I hear kind of in the machine learning space, people tend to use Python. What I find exciting about kind of this Python example is that I managed to build it without being very proficient in Python. So I think that's sort of the great thing here. So it's this link, the image search with OpenAI Clip. So it's an open source model, and the interesting thing here is that it turns images as well as text into the same vector space. So this means that you can perform image similarity search, right, by comparing the two vectors of images, for example, but also you can do text to image or image to text. So you can kind of translate between these different environments. And so this is kind of what this looks like. So we're basically putting the image data as well as the text data into the same vector space. And you can see here we have an image of two dogs in the snow, which then the text of two dogs in the snow, those two vectors are very close to each other because the context is kind of the same there. And so what we can do is we have this example. It is on GitHub. It is linked in the example as well. And what we can do is we can run Supabase locally, which is pretty nice. So because it's all kind of open source, it's already running. So, sorry, I'm typing with one hand here. I should say status, yes. So we're basically running the entire Supabase stack locally here. So we get kind of our API URL, we get a GraphQL URL, we have our database URL. So if we're kind of connecting directly to the database, we can use the Postgres URL here. And then also we have a Supabase Studio, and you can run that locally as well, which is quite exciting. So if you're, somewhere where you don't have internet, well, you do kind of, when you start, need to pull down some Docker images. So ideally do that before takeoff. But if you manage to start the service locally and have it running, you can actually develop, kind of offline, so to speak. So we have our default project here. We can kind of look at the table editor. We have sort of our public schema. We have a bunch of other schemas. So as I mentioned, we have kind of this auth service that sits on top of the database, and so we have kind of all the tables here in a separate schema there. And so if we now look at this example, let me just open it up in here, and I'm just using Poetry to run this, which is sort of kind of like NPM, but for Python, let's put it like that. And so here I'm just using Vex. So Vex is our Python client for vector handling vectors and embeddings. And so I have here my database connection. So I'm basically just instantiating a Vex client with my database connection. So this is here locally on my machine. And I'm actually using something here. I think this is it's open source as well. It's called Orb Stack, I believe. Orb Stack only found this recently, and it's basically okay. There we go. It's cinema mode now. So it's basically Docker running, sort of Docker optimized for Apple Silicon. So if you have a MacBook with like an Apple chip, then actually this will run Docker a lot more efficiently than say Docker Desktop or something like that. And I think it's open source, so that's pretty exciting. And so you can see here, by Supabase Start, I have all these different services running here. And then what I can do is I have my seed method, so I create my client, I create a new collection that I call image vectors, and we're using the OpenAI clip model here, which translates our images and our text into this vector with 512 dimensions, right? And then I have my model, so we're using the OpenAI clip model. And then I just have a couple of images just here from, maybe just remember those images. They'll be in the exam later. So this is the couple images we have. They're just from Unsplash. And so we're just encoding them here as a vector, and then what we're doing is we're just using our images collection, and we're just upserting our vectors here, and we can specify some metadata that we can also later use for kind of filtering in the query later on. Right, and then we're just saying, okay, we inserted the images, and we're creating an index. So after we're upserting kind of the images, we're basically creating an index to make the vector proximity search kind of more efficient. So let's say poetry run seed, and so we're doing all this, what I've just mentioned. We're generating our vectors. We're upserting them into the database, we're creating our index. And so now if we go back to our locally running, so this is running on localhost, kind of our dashboard. We now have a new schema called Vex. Can you see that in the back? Do I need to zoom in a bit more? And then here, this is our collection that we created. So this is our image vectors. You can see we have our IDs. These are our vectors, so you can see the column type here is vector, so that's the column type that PG vector allows us to store vectors, I think, of up to 2,000 dimensions, something like that. And then we have some metadata here, which is just JSONB, so we can use that to filter later in our query. So that's it, right? That was pretty easy. So now we can perform some searches here. Again, we're creating our client. Now in this case, we already have our collection, so we just get kind of a reference to our image vectors collection. Again, we're using our OpenAI clip model. And so now in this case, we're getting a query string from our arguments. We're encoding the query string into the same vector space as our images. And now we're just doing a query with our query vector, which is our text string. We're just limiting it here to the most relevant result. There's kind of other input parameters you can put in there. And then we can also filter on kind of the metadata, where you can just say, okay, we will only want to look at kind of vectors that represent sort of JPEG images, for example. And then we're just getting our result, and we'll just open up the result. So this is where it comes in handy if you remembered what was in the pictures earlier, because we're going to run some searches. Okay, who wants to start? I think I need to run search. What should we search for?
Open field.
Sorry?
An open field.
Open field?
Yeah.
Okay. Right, and so ideally now, and the reason why I called these 1, 2, 3, 4, there we go. I think that's where you applaud. Now, I mean, right? I think it is quite impressive because, like, if you think about, okay, you use this like on a daily basis. You use something like Google Images, right? And you can just search for like me on a bike, not me, like yourself on a bike, and it actually shows you all the pictures of you on a bike. But the tech behind it, right, is like if you think, okay, how do I actually implement this? Here you go. It's just a couple lines of Python code. Okay, I mean, obviously I could have been cheating here somehow. So maybe should we try another one? Just throw them out. Laptop. Well, I mean, that's interesting because we didn't have anything that's close to a laptop. So let's see what this model thinks is the closest to a laptop. To be fair, on your lap here, there could be a laptop, right? We don't know. Maybe the model knows a lot more than we do. Now that would be pretty mind-blowing if that was actually the case. Maybe fruit? Let's see, we did have some grapes in there. Yes, so we get our grapes. Anyone? Anything else? We did have a bike in front of a red brick wall. Obviously, if I put that in, that might be a bit too easy, but maybe if we just say vehicle. I think the bike was kind of the closest contextually to what we had as, yes, very good. It's like I practiced this. What else do we have? Okay, we had, so these are sort of both, I guess, flowers. No, I mean, oh, let's see, what happens if we put flower? Anyone has an idea how this model was trained? I don't know. Do we get the, yes, okay. I think that's fair enough.
How about something abstract, like
happy? Okay. That's true. Like, any predictions? What's happy? That is a happy remote worker working in a field. Fantastic internet connection. They are happy. All right. Yes. So the point I'm trying to make here is obviously right. Like the math behind this is fairly complex, and you know, like even if you're using something like Pinecone, actually, this is kind of a copy of the Pinecone example for image similarity search, but it is quite complex even still if you're kind of implementing this with Pinecone. But like for me, I don't have much knowledge of kind of the AI world. I don't have much knowledge of Python, and yet somehow a fun little demo came out, right? And so that's kind of what we're trying to do in general. We're trying to make Postgres more accessible to kind of a broader audience of developers, and here with sort of Supabase Vector as well, we're trying to make it easier to, you know, allow you to build kind of AI-enabled applications. Now, I think the subject of my talk was something like building your own ChatGPT. Obviously, let's quickly end on that one. Build your own ChatGPT here with Dino. So for the, you know, let's go back to JavaScript. Actually, who has here worked with Dino before? Little show of hands. Any Dino fans? Yeah, the Supabase folks. Yeah, that's true. Yeah, I love Dino. They probably have the best swag in the business. Somehow they found someone who can draw the cutest dinosaurs, and yeah, it just works, I think. Yes, there we go. Okay, so we're starting up again. Supabase start. We're starting our database here. I probably should have maybe opened the code before I ran this. This is yeah, well, it wasn't too bad considering how many Docker containers kind of are behind this. So now one difference here is we're using OpenAI to generate embeddings rather than kind of running the model sort of ourselves. So we're just going to the OpenAI API. We have kind of a pre-processing step, so maybe if we quickly look at the repository, you can look at kind of the different sort of things that are happening here. So we have a GitHub action, and basically the GitHub action, anytime we're kind of making changes to our docs. So we have like a bunch of markdown files with kind of context, and we put you know, that context, we generate embeddings for it. Because what we want to do is, you know, if you use ChatGPT and you asked something, you know, to ChatGPT, it doesn't have kind of the context that you're asking this question in, right? And so if we know you're, you know, developing with Supabase, we can actually get the relevant context from the Supabase documentation, give that to OpenAI, and make sure that the answer is actually only coming from this context, meaning that you can get a lot more precise kind of answers where, you know, like if I go to ChatGPT and ask like, what is PG vector? Or, no, I think the example is like, if I ask, what are embeddings? Then ChatGPT will reply with like, oh, in the concept of machine learning, you know, because it has to set all this context. But if I actually provide kind of the context of this query, I say, okay, we're developing with Supabase, and I ask the question now, what is PG vector? Then it knows the context, and we can provide kind of the documentation that we have, and then have ChatGPT actually provide kind of a concise sort of answer. Okay, and so we are pre-processing our documentation, we're generating embeddings, and we're storing them in the database. And so we can quickly look at where is our dashboard. Here's our dashboard now. This dashboard is now running our other project. And so here, I'm not using the Python client anymore, so this is all JavaScript. And so I just have here in my code base, I have one piece of documentation, which is this markdown file called OpenAI embeddings, and storing embeddings in Postgres. And so I'm just turning this into different page sections here, so basically all the different sections. And then I'm just generating a vector so that I can later perform kind of the search to find the relevant context. And then lastly, what I'm doing is kind of at runtime, basically when someone is asking a query, I then take kind of the query string here. What we need to do is we need to sanitize it, because OpenAI actually has some terms of service where you can't like ask the model some crazy things. That's against the rules, because otherwise it will get very rude, because it gets trained on all that. So you need to sanitize your query. You have your moderation response. So you're kind of asking basically OpenAI, hey, is this an okay thing to ask? Then OpenAI says yes, here's the sanitized way you can ask it. And then we create an embedding. Here we're using, I believe this is GPT-3 text embedding model. And we're now then performing our, we're using kind of a remote procedure call to perform our basically proximity search using kind of the JavaScript client here. So that's something that we'll have to make a little bit easier with Vex. You saw it was a bit easier to do that. But then what we can do is, we tokenize this. And then this is kind of the important piece. So we're generating this prompt where we're saying, okay, you're very enthusiastic Supabase representatives who loves to help people. That's important, so that the answer will actually be helpful. Given the following sections from the Supabase documentation, answer the question using only that information. And so that's kind of the crucial part where we're setting the context to be only the context of our documentation. We're providing the context of basically all the pieces of the documentation that are relevant to the user's question. And then we're putting the question in here, and then we're saying, okay, answer as markdown, including related code snippets. Sending that off to the OpenAI completions endpoint, and then we're just streaming back the response. Okay, and I think I'm running way over time here. So Dino task start, and basically the front end piece to this is fairly small. But what we can do here now is what are embeddings. And so if I fire this off now, we're looking at relevant information in our database. We're sending that off to OpenAI, and then we're streaming back kind of the response. Now, if I put in what are embeddings just into ChatGPT, then it will say, like, in the context of AI and machine learning, yada, 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 it will be a lot kind of longer response. Or I can say, can I store embeddings with Supabase? Let's see if the typo is fine. Yes, PG vector, lovely. And then, do we have time for questions, or should we go straight to Brooklyn's talk? What do you think?
QA time.
Sorry? QA time? Okay.
For yourself.
For myself. Did anyone ask any questions? Let's see. Where was the... Okay, no, I don't have the... No questions? Okay, we have questions in the room. Let's do that. Yes.
So my question is, like, what are the benefits and downsides of a PG vector versus a specialized vector database like Uncut?
Yeah, that's a good question. Yeah, you probably would need to ask an expert for that. I think we have some things in the documentation. I mentioned one kind of the benefits is you have it kind of in the same database space, and so what you can actually do is you can create views to expose parts of your vector data into kind of the public space. So like the way you develop your application, basically you don't need, like if you're building an application with Pinecone, you likely still need another database.
So it's more versatile.
So yeah, I think it's more versatile. It's kind of easier to get started. You have kind of everything in the same place. I think maybe one thing is, like Pinecone, I think actually has some proprietary models that they offer sort of internally, and that's something that we don't have. So I think for some specific use cases, you might be better off using Pinecone because they kind of have these specific models. Whereas for us, we don't run any models for you as of yet. So we're looking at ways to actually run open source models kind of right within your database or very closely co-located. So yeah, I think for now that's kind of that, and then we're kind of in the progress of running sort of benchmarking in terms of actual performance and like, you know, scaling. So I think that's something where you're immediately concerned about like, okay, I'm going to have huge workloads and I need it to perform out of the box without any like fine-tuning of indexes. Then potentially you're better off going to Pinecone kind of today versus we're still kind of looking at, okay, what are the best indexes to create kind of for the different use cases, and how can we sort of scale, scale beyond. And I'm not sure kind of the amount of dimensions that Pinecone can do, but so PG Vector currently is limited to, I think 2,000 dimensions, yeah. Yeah, that was one.
Yeah, so I'm curious about when document lengths get longer. Is there like a limit beyond which you're saying, okay, I should start chunking these and generate vectors for them separately?
Yeah, I think what we're doing right now is kind of we're looking at sort of page sections, and I think it's mainly sort of broken down by headlines, so kind of using the markdown and sort of breaking that down into sections. And then what we're doing is actually we're generating kind of a checksum for the different pages to make sure we're not constantly regenerating the vector if the information hasn't changed. But like the exact numbers of like how you should be chunking, I'm not sure. There is some, yeah, you know?
Yeah.
Yeah?
Yeah, so for, I think OpenAI's API, they have a token size of like 4,096 or something like that. Yeah. And obviously if you want to convert something, I think it's not really recommended because like send a whole chunk of text and use up the token limit. Like I think it's recommended to actually break them down into smaller chunks and have overlapping chunks so that you have more of a like contextual representation of the data. So when you perform like, any similarities such as, you get better results from that.
Okay, so then the question I would ask, follow up on that is, apart from just plain cosine similarity, do you have any other way of also returning the like paragraph before and after that you kind of bring not just that answer but also the paragraphs around it?
I'm not sure if that is specifically built in. I don't think it is. Like in the schema, we basically have kind of the section sort of related to like the parent page, and so you can fetch it kind of based on that. But yeah, I don't think it's specifically built in. So it's kind of like you can customize it if you know enough SQL. Another way is using LangChain. So LangChain, I think, provides a bunch of like helper things, especially around like chunking and sort of preparing searches. And so LangChain works with Supabase as well. There's like an example documentation they have. Yeah, early days, but we're working on it. Cheers. And I think there was one more question. Yes.
Is there any way to combine like your vector search with a relational query? So you could say like, show me all users who uploaded an image of this type, like that. So you could put that into your wheel.
Oh, interesting. So yeah, I guess I mean, so there's like the metadata itself that you can provide a query on, and then I guess you can.
Or you could think of extending this wheel that you have like an addition where like you have like hard constraints or
Yeah.
technical, and then you have in addition for matching on vector similarity, like when this threshold.
Yeah, no, I think you can probably make it work. I haven't looked at it, but that's a good point. Yeah, like
Because then you would have an advantage over
that you can combine kind of the relational.
yeah, if you have like if the claim is you have all the information in one place and you have other
Yeah, so let's say yes, yes you can, and that's another benefit of. Yeah, I think you can make it work. Probably using views. Yeah, that's a good idea. Thank you. Okay, and I think any other burning question? Otherwise, we'll pass it on to Brooklyn, who's got a really interesting talk on Rust. Basically, building for Node.js in Rust. If you really hate JavaScript, you're going to love this next talk. All right, thanks so much, and Brooklyn, please.
Okay. Hey everyone. Today I will talk about developing high-performance Node.js add-ons with Rust and NAPI-RS. First of all, let me introduce myself. I'm the creator of the NAPI-RS, and I work at Vercel Tupac team and ByteDance, LeetCode, and Team Vision before. And I'm now leading the Octobase team at AFFiNE, building the local first cooperative infrastructure for developers. So recently, we have heard a lot of popular front-end tools are rewriting with Rust, and they are all in the Node.js ecosystem. And as you can see, they are all choosing NAPI-RS. And what is NAPI-RS? First, in simple terms, NAPI-RS is the bridge between Rust and Node.js. And as you can see, all the front-end tools are performance-sensitive libraries, and they are choosing Rust to rewriting their slower JavaScript components and replacing it with Rust. And what's the features does NAPI-RS have, and they cannot resist to choose it. First of all, NAPI-RS allows for very concise syntax to turn a piece of Rust code into a function that can be directly called in the Node.js and JavaScript. Compared to the other Node API frameworks in Rust or other languages, NAPI-RS does not only generate a callable library and binary, but also generate corresponding DTS files for TypeScript projects. This is the first big advantage of using NAPI-RS. In the code example on the left, we can see that with just a few lines of Rust code, we can provide a functionality of Rust library UUID to any Node.js caller. And not only it includes the function of UUID v4, but it also provides amazing performance compared to the crypto random UUID provided by Node.js itself. is about 13 times faster. As you can see the screenshot on the right. So here is a more complex example. Let's pretend we are building a bundler with using NAPI-RS and exposing plugin API to JavaScript here. The bundler function takes a parameter called plugin here, which accepts a string passed by the bundler. We will assume that this string is the source code we want to process with, and the plugin function returns a promise string types pair. And let's take a look how NAPI-RS handling this situation. From the implementation of the plugins, we can see that there is TSR type is used to override the types automatically generated by NAPI-RS. This is because the Rust type system is very different with Rust type system. So NAPI-RS may not be able to generate perfectly TypeScript types automatically. Therefore, there are some APIs for developers. We can declare more precise types using the APIs. In the specific logic, we pretend that the code is the source code that the bundler needs to process and pass it to the plugin API. The call async here means that we are async waiting the return value of the plugin function, so that we will not block the execution of JavaScript here. The biggest magic here is the promise written from the plugin can be directly awaited in Rust, and here we await the value from the promise and return it to JavaScript side, just like dump bundler do. Returning to the generated DTS files from NAPI-RS, we can see that the async FN in Rust returned a promise value in JavaScript, which means you can also await the async FN in JavaScript directly. Okay, this is a simple example for a dump bundler. So as we can see, we can call the bundler in JavaScript like this. Here is a classical style Node.js callback for plugin API, where the first argument represents whether an error is happened here, and from the screenshot in the right, once we run the JavaScript file, we can get the result from the bundler. Here we pretend we are transform our source code with SWC here, and process it async. So now that we have learned about how to develop an NAPI-RS module, it's time to start thinking about how to distribute it. In traditional native add-on solutions, developers may use post-install scripts to compile native code during the installation, or download the pre-compiled binaries from CDN or GitHub release. You may have gone crazy dealing with various post-install script values when using another native add-ons. One of the best features of NAPI-RS is out-of-box pre-compiled and distribution solution with zero post-install scripts, which is especially convenient for GitHub Actions users. Of course, NAPI-RS also has other advantages, such as compatible with serverless environments, such as Vercel or Netlify. In terms of pre-compile, NAPI-RS maintains a complex toolchain that supports most of mainstream platforms on the market. In this big table, you can see which shows the NAPI-RS can pre-compile add-ons for particular work platforms on which Node.js can run. In addition to the multi-platform pre-compiled solutions provided by GitHub Action, NAPI-RS also offers cross-platform compilation solutions for other CI platforms like CircleCI or GitLab CI. You can use NAPI-RS CI to compile binaries for the following platforms only on Linux and macOS. And it's really easy to integrate into your own CI scripts and your workflow. Okay, up until now we have been talking about the advantages of using NAPI-RS, but if it had no drawback, why haven't I rewritten all the packages on NPM using NAPI-RS? So now I will discuss some of the trade-offs using NAPI-RS or similar technologies. It's including the following points. The first is cross-boundary overhead. We all know the Rust is very fast language compared to JavaScript, but you may not know there are many core overhead if you calling a Rust function from JavaScript. So I will talk about it later. And the second one is trusting. And the final one is debugging. Let's start from the cross-boundary core overhead. Contrary to making complex tasks, this table shows making Rust to do a simple calculations and wrapping them with different Rust NAPI frameworks, then comparing them to pure JavaScript with the performance. You can see that in the simple computation, JavaScript can be several tens to hundreds of times faster than Rust. But why is the case? Hell, shouldn't Rust be much faster than JavaScript? Actually, it was cross-boundary core overhead I mentioned about. Cross-boundary core overhead refers to the performance cost occurs when making function calls between different binaries and languages. In the case of Node.js and Rust add-ons, they are compiled to separate binaries. You know, Node.js is a single executable binaries, and your add-ons is another dynamic linked library. So traditional native language compiler optimization technologies such as LTO and PGO and such things do not work when making a cross-binary function calls. Secondly, the call cross the function call cross the JavaScript engine. So there is a lot of additional work to make to be done during the core, resulting in more performance overhead. As we can see in the sum function in the right section, in addition to the necessary A plus B operation, there are 5 additional Node API calls compared to the pure JavaScript implementation, which are used to handle, type conversion and different for the different runtime and the language. And the cross-boundary calls also cause another issues. In this example, the pure JavaScript implementation has the opportunity to be deeply optimized by the JavaScript engine like V8. But however, in the implementation on the right, the inserted native add-on function may cause the entire some hot path function to be abandoned by the engine for optimization. So this will introduce more overhead here. And the second trade-off is trusting. There have been more and more news about attackers using NPM to distribute their codes to steal secrets from developers and users. So using NAPI-RS or the other native language to publish native add-ons to NPM will increase the will exacerbate this issue, as the released binary cannot be effectively added by the tools like however, this situation has recently improved as the NPM officially released the provenance feature for sign published NPM packages, preventing them from being tampered with during the publishing process. Okay, the third overhead here is the debugging. In order to reduce installation size, most NAPI-RS packages just drop their debug symbols during the release, and the screenshot here is from the issues on the official RSpec repo, which shows that when issue or panic happens, the error stack cannot be displayed at all because the debug symbols was removed during the publish, making it much more difficult to locate and fix the problem on the developer side. To solve this problem, NAPI-RS will provide a debug symbols download feature in the next major release to reduce this problem. And if you want, and you can download the removed debug symbols again if the panic happen on the developer machine. Okay. So conclusion is NAPI-RS is very easy to use and provides an end-to-end solution from development and deployment. And NAPI-RS can improve Node.js performance progressively, and not all scenarios are suitable for developing with NAPI-RS and Rust. So that's all. Thanks.
Any questions?
Any questions?
I have one question. So like, given all the overheads that you mentioned, how do you weigh the trade-offs between like when to optimize some part of your like JavaScript code and switch it over to use Rust? Yeah.
It depends because even I have written thousands of NAPI-RS libraries, but I can't give an answer that which parts of your application can be rewritten by Rust, because it needs to be profiled, and as you can see, the Rust code may for example 10 times faster by JavaScript compared with JavaScript, but it could introduce more overhead, like de-optimize your JIT in Node.js or some other overhead we can't see in pure JavaScript application. So the only way to do that is rewrite small pieces, which introduce less core overhead, like less Node API calls, and profile it.
Than your Node.js implementation.
Yes, maybe RSpec is a great example. RSpec is a library which has the same API with Webpack. It has the same API and the same configuration and the same features, but it's 10 or 20 times faster than Webpack in boundary. Yeah.
And it is built with NAPI-RS.
Yeah.
I heard it was 5 to 10 times. You said 10 to 20 times.
It depends on projects. Yeah. If you are using like less loaders and if you are using more JavaScript written loaders and the plugins, it will be more slower. But if you are using the built-in functions like TS transpile or CSS transpile, it will be much more faster.
Is the AFFiNE backend written in Rust?
We don't have a backend server right now, but we have a universal infrastructure for cooperative and real-time cooperative, and it's written by Rust. And in our election client, part of the data processing layer is rewriting by Rust and NAPI-RS to replace the JavaScript version. Yeah.
I'm curious, if you want to use Rust on the back end, why did you choose to build on Node and NAPI instead of going with Dino, which is native?
Yeah.
And you could skip the C API.
Yeah, it's a good question. We have tried to build our business codes on Rust before, like CRUD business code, and it's really no productive for engineers because it has a very complex type system and borrow check, and we can't ship our features before it changes. Yeah. So in most cases, I think Node.js and JavaScript is more suitable for this business. But in other scenario, like AI, like our business model, like cooperative and real time performance sensitive scenario. We need to replace the part of Node.js application with the Rust. Okay. Any other questions?
By the way, if you ask questions, we will have swag for you. Like free t-shirt. Yeah.
Can I have some swag?
I see that your NAPI-RS will do some preview for the matrix of the OS and architecture, right?
Yeah.
So what will happen if the user is using some new architecture that
you can still compile your own binary if you want. It's not conflict with the pre-compiled version.
That's the possible install script.
Yeah.
Okay.
But for the mainstream OSM platform, it's not necessary. Yeah. Okay.
Actually, I have a question for when you are thinking about like using Rust to write an API-RS. Is there any thoughts that you might want to use Zig? Yes. I mean, how do you compare like the performance between like Zig and Rust when you are writing like a build or how?
You mean Zig? Zig now?
Yeah.
From my knowledge, Zig is a fancy C. It needs to manage your own memory by hand. So if you go to the bound.js issues, you can see a lot of segmentation faults and panic issues here because of this. But Rust is different. It has borrow checking and it will manage your memory automatically. So it's more memory safe in this way, and I think it's more convenient and trustable for the infrastructure. Yeah.
Okay.
I think.
Awesome. Yes. One more round of applause for Brooklyn. And please also one big round of applause for Michael, who's been recording this as part of Engineers.sg. Thanks so much, Michael. And also, big thank you to all of you for spending your time with us tonight. Very much appreciated. If you could give us some feedback, that'd be great as well. So we can see what we can improve for next time. And lastly, we do please scan the QR code. Lovely, we can see some folks coming in. Friends invitation, lovely. Real life connections still a thing. That's fantastic. And then lastly, we have some pictures. So there's a Google photo album with pictures from tonight, if you're interested. We'd also love to take a group picture. If that's something you're comfortable with, then maybe where should we go? Who's the lightning expert? Lightning, that's me. Who's the lighting expert? This wall back there, does that make sense?
But before that,
Yes, sorry. Okay, so we'll have some wrapping up words and then we'll get ready for the group picture. Cheers.
Thank you. Right, so I'm founder of AFFiNE, and my name is Jiachen. First of all, you don't have to give me any questions to pick up the really delicious fried chickens and hamburgers over there, because we really prepared a lot of snacks, and it seems like nobody's hungry left. Right, so thank you all for the time and the questions to listening about me and my friends talking about our stories being a startup. And there was a problem about why did we decide to open source our backend? And many companies didn't do that because most likely open core company relies on those sort of your services so that there's traffic and incomes. And like for AFFiNE, a local first believer, we have 3 projects which is AFFiNE and the infrastructure behind AFFiNE. That is our front end apps framework, block suite, and the databases, as well as the backend serverless framework, which is called Octobase. They are underdeveloped. But first of all, we hope AFFiNE can be something like a VS Code for non-coders. If you think about it, the game industry and the developer tools industry has all been revolutionized by open source plugin systems. Like with Unity and other stuff, you can easily build a game with 2 or 3 people. Like with VS Code plus plugins, you can have IDEs for different languages. But like 10 years ago, only the most popular languages have more than IDEs. Like we see the same thing in productivity and collaboration tools. Right here, of course, here comes Notion, Miro, Airtable. That is a modern version of just Word, Excel, and PowerPoint. But you don't have specified versions for architectures, for designers, for all kind of different people. And we think the only future it is possible to keep the data to the user is to let them have the ability to form and customize their own tools. It's like more than SaaS application, it's like giving people cans, but didn't give them can openers, right? So you can download some data and export data from certain softwares, but that is only bounded to that software. So we decide to fully open source everything we do from day one, because we hope AFFiNE can be an open source VS Code for non-coders. That's why we go with JavaScript. And we go with NAPI-RS, because sometimes if it's taking a bit slower, we trust to believe the myth of Rust. And we hope this service can be embeddable, integratable with your existing systems. And in AFFiNE, we not only make rich text editors, we make all kind of editable components. Like there are majorly 3 classes, which is rich text editors, editors that can transform your blocks of information into workflows, like tables or Gantt charts and stuff for project management or queries. And lastly, we also made canvas-based graphic editors. And I didn't mean 3 different types of editors. I mean 1 editor with different support. It is like if Monaco is the core of VS Code, then Block Suite, the core of AFFiNE, is the first framework that can allow you to deal with graphics, rich text, and data in the same time, just like how Thor play with that embedding of the picture and text together. So we're open source, and we hope our plugin system can be widely used by more people so that people can have their own tools and data. And in the future, we hope we can make JavaScript not only the best way for websites, but also JavaScript-based applications. So that's what we want to see, and there's many things, little games we brought here, and our food. So please feel free to pick them up, and thank you again for everyone.